Scientific revolution, scientific methodology. One of the most important themes with all of these men is their reliance of new methodology in science. And speaking of what we know now as the scientific method, it's impossible not to discuss the impact of Francis Bacon and Rene Descartes. Francis Bacon was an English politician and writer who rejected the speculative reasoning of Aristotelian science and favored hard empirical research. The researcher who wants to learn more about rocks should not speculate about the subject, but rather collect numerous specimens and then compare and analyze them. General principles will then emerge. Bacon's contribution is the inductive method, also known as empiricism. Experimentation and the systematic collection of data could then be used to come up with some sort of general rule or principle which accounts for these facts. The opposite of this method was known as the deductive method, or the work of Rene Descartes. Descartes initially made his name as a brilliant mathematician. He saw that there was a perfect correspondence between geometry and algebra, and that geometrical spatial figures could be pressed as algebraic equations and vice versa. This is the development of analytical or Cartesian geometry. Still, his greatest achievement was to develop this vision into a whole philosophy of knowledge and science. He began to doubt everything, both religiously and scientifically, until he was left with his own existence. Quote, cogito ergo sum, or I think, therefore I am. As in geometry, you needed to apply deductive reasoning from self-evident principles to ascertain scientific laws, thus using general rules and principles to make specific rules. Descartes' reasoning ultimately reduced all substances to either matter or mind, that is, the physical and the spiritual. This view is known as Cartesian dualism. Nonetheless, it's the synthesis of Bacon's inductive and Descartes' deductive reasoning that gives us our modern scientific method. There were other important figures of note in the scientific revolution. In the area of mathematics, not only did you have the aforementioned Newton, Leibniz, and Descartes, but John Napier, a Scottish mathematician, who published a vast table of natural logarithms. Using his simplified method, Edmund Wingate and William Oughtred invented the slide rule in 1630. In anatomy and medicine, the Renaissance saw the first challenges to the rules of the Greek physician Galen. At first, Andreas Vesalius prepared the first modern textbook for medical schools that was based upon intricate human dissection. Secondly, William Harvey was the first to demonstrate the functionality of the heart and the circulatory system. In chemistry, Robert Boyle must be mentioned. Boyle was the first to make a clear distinction between an element and a compound and to define clearly the nature of a chemical reaction. Also, his namesake law, which states that assuming that temperature remains constant, the volume and pressure of a certain quantity of gas are inversely proportional, K equals PV. Making much of this possible, as in art and humanism in the Renaissance, there were channels of patronage. Here, many governments established societies to promote research and glorify nations. The most famous of these were the Royal Academy of Science, founded by Charles II in England in 1662, of which Sir Isaac Newton was the leader, and the French Academy of Science, established by Louis XIV at the suggestion of Jean-Baptiste Colbert in 1666.